Hi guys, today we're going to be looking at a question on acids and bases. A hydrogen bromide solution, HBr, reacts with water according to the following balanced chemical equation. The Ka value of hydrogen bromide at 25 degrees Celsius is 1 times 10 to the power 9. Question 7.1. Is hydrogen bromide a strong acid or a weak acid? Give a reason for the answer. So hydrogen bromide is a strong acid, and we know this because the Ka value is greater than 1. As it is 1 times 10 to the power 9. Question 7.2. Write down the formulae of the two bases in the above reaction. So, if hydrogen bromide is the acid and it has to react with the base, our one base will be H2O. And then we would also have our conjugate base pairs and our conjugate acid pairs. So, HBr, then, being an acid, donates a proton, and we remain with Br, which would be the conjugate base. So our base would be Br minus. Hydrogen bromide reacts with zinc hydroxide, I think, according to the following balanced equation. I think this is zinc hydroxide, that could be wrong, but this is the formula. The unknown quantity of zinc hydroxide is reacted with 90 centimeters cubed of hydrogen bromide in a flask. Assume that the volume of the solution does not change during the reaction. The excess hydrogen bromide is then neutralized by 16.5 centimeters cubed of sodium hydroxide of concentration 0.5 moles per decimeter cubed. The balanced equation for this reaction is, this equation. Question 7.3.1. Calculate the pH of the hydrogen bromide solution remaining in the flask after the reaction with zinc hydroxide. So we want to calculate how much is remaining in the flask before the reaction with sodium hydroxide. Therefore, we can first calculate how much of hydrogen bromide reacts with the sodium hydroxide. We first need to calculate the moles of sodium hydroxide. And we can do this as we know the concentration is 0.5 and our volume is 0.0165. Or you could have said 16.5 times 10 to the negative 3, as this is centimeters and we need to convert to decimeters. If we plug that into the calculator, we'll get our answer to be 0.00825 moles. Then, looking at our formula, we know that hydrogen bromide and sodium hydroxide are at a 1-to-1 ratio. So we can conclude that the moles of HBr, which is essentially an excess, is equal to 0.00825 moles. We can then find the concentration of the HBr, and since it's a strong acid, it has hydronium ions. So the concentration of the hydronium ions would be N over V, which in this case is our N value over here, over the volume, which they say is 90 centimeters cubed. So if we convert to decimeters, we should get 0.09. And if we plug all of that into the calculator, we should get 0.092 moles per decimeter cubed. We can then calculate our pH by saying negative log concentration of the hydronium ions, and we plug in our value that we just calculated, being 0.092, and if we put all of that into the calculator, we should get 1.04 to be our pH. I'm going to do the last question on a new page so there's space to work out. Question 7.3.2. Calculate the mass of zinc hydroxide initially present in the flask if the initial concentration of HBr is 0.45 moles per decimeter cubed. So to do this, since we have the concentration of HBr initially, we can determine the moles of HBr in the initial reaction, saying our concentration times by our volume, which is still 90 centimeters cubed. Therefore, if we convert to decimeters, 0.09, and we should get 0.0405 moles. We can then determine how many moles of HBr reacted with the zinc hydroxide. And we can do that by saying our initial moles minus the moles we have at the end, which is then used in the second reaction, which we calculated to be 0.00825. And from that, we should get 0.03224 moles. Then, by looking at our equation, we can see that zinc hydroxide and hydrogen bromide are at a 1-to-2 ratio. So, we know that the amount of moles of zinc hydroxide is half the amount of moles of HBr. And when we calculate that, we should get 0.016125 moles. We can then calculate the mass, zinc hydroxide, by saying the moles times the molar mass. Our moles being the value just calculated, and the molar mass, which you can find on the periodic table just by adding each of the atoms, we get to be 99. And when we plug all of this into the calculator, we get 1.596 grams. And that's all for this video. Thank you.